Hello friend, welcome back in online lecture series. I am Dr. Keshao Mahale. Today we are going to discuss the phosphinate phosphorus ylide. In preceding lectures we have discussed the phosphorus ylide phosphorine. See, this is the structure of phosphorine. See, one with the phosphorine and this is the phosphonate. What is different between these two phosphorus ylide? Here is the phosphorus having 3 alkyl or aryl group. Here is the phosphorus having 3 alkyl or aryl group. Here is the phosphorus having the alkoxy group, 2 alkoxy group, and one is the phosphorus double bond oxygen. One is the phosphorus double bond oxygen. See, this is the phosphonate. This is the phosphonate. So these are the two types of phosphorus ylide: phosphorine and phosphonate. In last lecture, we have discussed the reaction of this phosphorate and also the preparation of this phosphonate. Let us discuss now the preparation of phosphonate and its reaction. Phosphonate is preferable phosphorus ylide as compared to the phosphorate because here is due to the phosphorus double bond oxygen and carbon double bond oxygen, carbonyl, it is very stable reagent. So let us discuss here the preparation of phosphonate. See, this is the phosphorus, this is OCH3, this is OCH3 here, and this is OCH3 here. So trialkoxy phosphorus when react with this compound, this is the bromine here, this is C double bond O, and this is OET here. Now this lone pair on phosphorus will add here, bromine will be removed, and then after we got here OCH3 phosphorus, OCH3, this is OCH3, this phosphorus now having positive charge, and this is CH2, this is C double bond O, this is O. Now the bromine which will remove here in this state will be attached to this CH2, this bond will be shifted here, and we got here, this is OCH3, this is phosphorus, this is OCH3, phosphorus double bond oxygen, this is OCH3, and this is the CH2, C double bond O. Now by using this here, we can generate here the carbanion to this carbon atom, and here is the formation of phosphate. Here is the formation of phosphate. Friend, this reaction is known as the Arcusov's reaction or the preparation of the phosphonate. Let us discuss here its synthetic application. In synthetic application of phosphate, we discuss here the Wittig-Horner reaction. Wittig-Horner reaction. Wittig-Horner reaction is the same as Wittig reaction, only the different in this reaction. In Wittig reaction, the phosphorus ylide is the phosphorate, and in Wittig-Horner reaction, the phosphorus ylide is the phosphatate. So let us take here the example, the general mechanism. This is the carbonyl group, ketone, this is the ketone compound, when react with phosphatase, this is CH2 minus, this is C double bond O equal. Now it will be attacked here and double bond will open and got here, this is R, this is carbon, this is R dash, this is the oxygen O minus here, and now this is CH here, this CH is attached to this phosphorus having double bond O, and here is the OCH3 twice here. And see, now this negative charge attached here, and this is the negative, there is formation of negative charge, or after the get back bonding, this OCS will be removed here, and this is the further part, this is C double bond of OA. Now here 4 member, this is R, C, R dash, this is O, this is CH, this is phosphorus, this is having OCH3, this is phosphorus double bond oxygen. This is C double bond O equal. Now by elimination reaction, there will be formation of olefin R C double bond CH. This is C double bond O, and this is O equal. And here the removal of phosphorus. So this type of. This is the simple mechanism by which we can prepare olefin by using the phosphonate. Example of Wittig-Horner reaction, in which we have to convert the ketone into the olefin. See, this is the acetophenol that we have take here, and this is the phosphonate compound, that is the phosphorus ester. So in this reaction, this negative charge will be attached to carbonic carbon, and this bond get open here, and we got here, see, this is the carbon, this is the oxygen here, this is the CH3 here, this is the phenyl ring. Now this carbon attached to this carbon, and it has the 2 methyl ring, and one is, this is the phosphorus here, this is double bond O here, this is OCH3, and this is OCH3. Now this oxygen having here the negative charge. This negative charge attacks here, this bond get open, again get removed, and this OCH3 will be removed here, and we got here the 4-member cyclic compound, that is the phosphatase type of compound. So this is pH, this is CH3, this is CH3 here, this is O, this is phosphorus which having double bond, and this is OCH3. Now by the elimination reaction, this bond gets hit here, this bond gets hit here, and we got here the olefin, this is CH3, this is carbon double bond carbon, this is phenyl ring, this is CH3, and this is CH3. And here is the formation of, phosphorus ester. Here is the formation of phosphorus esters. This is the phosphorus ester which is formed here as a byproduct. Friend, Wittig-Horner reaction is preferred over the Wittig reaction in the preparation of olefin from the ketone. This is asked for the reasoning type of question in the examination. So question is like this: Wittig-Horner reaction is preferable over the Wittig reaction in the preparation of olefin from the ketone. So the reasons for this reaction is preferred over the Wittig reaction are? See, firstly the phosphonate Ylides is stable over the phosphorate. Phosphonate Ylide is more reactive towards the ketone as compared to the phosphorate. Then after, if some ketones have electron withdrawing group, at that time they are acts as an inert compound in the Wittig reaction. So at that time, if we use here the phosphonate Ylide, then it will be give us the reaction, and if we use their phosphorate, then it will be not give the reaction. Phosphonates are chips and Ag2 prepared by the Arkhizov's reaction or the phosphorate, and finally the byproduct in Wittig-Horner reaction, that is the phosphorus ester, which is soluble in water and Ag2 remove, and hence we use Wittig-Horner reaction preferably for the preparation of olefin over the Wittig reaction. Thank you.